Hope you guys are doing well. So, continuing on our journey, today we would start with uh, we'll we'll try to understand. Uh, so we left off with NumPy. Uh, let's close. Yeah. So okay. So we were with NumPy. So we did see how uh NumPy's arrays are made, right? Uh, so we'll continue with that. We saw how NumPy performs better, right, as compared to other other how as compared to normal looping. How NumPy performs much better. And we'll see. So first, what we can do is let's open our terminal, and then let's let's list out. So let's go to my let's go to my Jupyter env. Okay, now did I misspell it? It's Jupyter. No such. Oh yeah, I am already that. So mm, let's pin up Jupyter. I always forget the file name. So there is that ZCRH file, right? I can go back though. So let's go cd dot and then let's have this thing. That is where our command is, right? So let's see. Work on Jupyter. Oh, so it's already alias, so that's okay. Let's pin it up. Work on hyphen. They should automate. Oh, I missed R, I guess. Let's get rid of work on hyphen. Uh, yeah, so it's running. Let's now go to. Okay, but then the thing is, does it automatically open in that? Let's open another terminal. Let's go to. No. Let's have another terminal running. Let's close this. Let's minimize this thing. Yeah, there is a way which you can open another one. So you do right new window, and then you do. Let's go to my Jupy, my Jupyter env, and then let's do. Oh, is it? I guess I have to do it over here. Oh yeah, it's already. Um, I guess it's already open. Let's pin up yes. Let's open normal way. Where did it go? It disappeared though. Just let me check. Let's go to finder. Just let me end this thing. Let's open a how did VS Code disappear? Okay, so let's close this. Uh, yes, I have VS Code open. Now let's terminal. Now let's say this is oh, it has to be that IPYNV, right? Python notebook. It will be on Titan itself. It's reset. Let's import. Import NumPy as NP. Now we need to change the kernel, right? So when you go to kernel, Jupyter, or Python environments, and then there will be wait. uh let's go to that Jupyter. Yeah, let's open it over here. No. Let's inside this. Let's have a Now does it say import? Yeah, and it won't work now because yeah, now it will work. Okay, so what I can do here is, let's get rid of this thing. Get rid of the file from here. Not inside bin. And then let's have this thing out. Oh, instead of doing that, let's just delete it from close this thing. Notebooks and then test1.py. Let's do markdown. Let's import Python environment. Yeah, so I have imported. Let's get back. So basically, we studied about ND arrays, right? We said ND arrays were the basic fundamental block of now arrays are of storing data, right? Or we did np dot zeros and np dot. We also saw the data types, right? The a range is like range, so that's okay. Now arithmetic with NumPy. Arrays are important because they are enable us to express batch operations, right? So yeah, NumPy arrays are important because you can do multiple things at a time. So let's first of all so first basically we'll see adding to arrays or multiplying to arrays. So let's see arrays np dot. Now we'll use array and then we'll pass in a probably a tuple. So this is 1 2 and then the rules of matrices have to hold true for multiplication, and this is array 2. So let's take a easy thing. These are all batch operations, right? What if I try to do what if I'm trying to multiply it? It shouldn't give me. Let's see what does it give me now. So what has happened? Oh, multiplying with 1 2. Again, this is in one go, right? Uh, Again, this is 1 cross 4, right? This is 1 cross 4. This is 1 cross 1. Why is this multiplication happening is because here we are thinking is of as a batch operation, right? Now, how that is happened, there is something called as broadcast, right? Uh, so if you think logically, this multiplication should have be taking place. What is happening and how it's happening? So there is a rule, right, for matrix multiplication, right? Okay, so what has happened is, Mhm. And this is not connecting today. I don't know why. So even if you see, there should be an issue, right? Uh, like this shouldn't get multiplied. This shouldn't work. So you're saying so there is something called as broadcasting, right? When an array has a shape and another has the shape 1 comma, NumPy automatically structures the smaller array to match the shape of the larger one if the dimensions are not compatible. So what it does is there is something called as broadcasting that happens. So there is something called as uh, I hope so now it connects. Oh yeah, finally. Let's put this there. Let's see what broadcasting is. Uh, So by rule of thumb, if multiplication has to happen, then so if this is a m cross n matrix and even this is a m cross n, right? So the rule for matrices say that this has to match. Even though so our the matrix that we were considering, we were doing this is a one cross four matrix, right? And then this is a one cross one, right? There is no match over here. But even there is no match, still the multiplication is happening, right? So what does NumPy do is it kind of does something called as broadcasting. Now there are rules for broadcasting. Now when two arrays, now NumPy compares the shape element wise. Broadcasting can happen. Now when can broadcasting happen? So when can broadcasting happen? First is uh, when dimensions are equal, then there is no need. When dimensions are equal, or when one dimension is out of the two arrays, one has a dimension of one. Like so, here basically, uh, if we see in this one, the dimension is one, right? So what it is going to do is it is going to make this array as compatible with the other one. That is, it is going to expand it and going to make it a shape of 1 comma 4. So you have 1 rows and 4 columns. This is called as scalar broadcasting, right? If that operation is not matched, then you'll get a 1D error. You'll get an multiplication error. Even after broadcasting, right? Uh, how is that? Now this is something cool, right? Remember, we said we are doing vectorized operations, right? We're not doing individual elements operation. So if I do star, then it is element wise, right? Only the shape must align. Now if I do dot, then so there are two rows. So this is one way, right? This is star. Now this is something which is basically uh this is element wise multiplication. So even whenever you are doing element wise multiplication, the dimension should not there is no issue with the dimensions. Right now when I do np dot, so if I do np dot, and then now if I do, so have to be two array, like okay, let's do np dot, and then I do array 2 and array. So now this should give me an error, I guess. Yeah, see, I got a value error, right? That too at this line. Shapes are not aligned. See, saying 1 does not match with 4. So that is the same issue we are having over here, right? We said even 1 and 4 there is no match. So linear algebra rules are not uh, are uh, are violated, right? When you are doing star wise multiplication, so there are two operations here. So either I do plus or star. Now this is element wise. Remember, these are all. If broadcasting can be done, and here is when that broadcasting rule will come. So this is when we have that broadcast. Now whenever we do a dot, or when we say uh, dot multiplication, now this is where all rules of linear algebra will hold true. So yeah, this is basically, this is element wise broadcasting that is going to take over. So be careful the way we do multiplication, right? But even for addition there are rules. So this is something else. Now, okay, now these are so that is what he's saying. Arrays are important because we are doing something called as vectorization, is because we are doing element wise, and then we are not doing something, even comparisons. So comparison is going to be vector wise. If broadcasting can be done, then it will hold true. Now indexing and slicing, again it will be zero indexed, right? uh Now there is difference between, so you can do slicing in tuples as well, right? Let's see how that slicing is going to work here. So I already have an array, right? So if I do a slice, say give me a slice of it, say I go from 2 to 3, or 2 to end, I say. uh so now what is going to happen is, so I'm going to get a new array, right? So this is 0 1. Yeah, let's keep this thing as well. So this is 3 comma 4, right? So this is 0 1 2 and 3, right? So from to you till end is what I have mentioned here. Now see, an NumPy array indexing is rich. There are many ways you can subset of data. So this is basically to create an array, right? So 10 is like 0 to 10, then you can mention step size as well. Now if you can see, if you assign a scalar value to a slice, for example, if I do array 5 is to 8, the value is propagated or broadcasted and to the entire selection. So if I say this to 12, and then if I run this, you know, and if I say print this thing, so what is happening here is, just print this off. So there is some error, which is expected parameter, let's say 2 to 3. Is it double? If you can see, if you assign a scalar value to a slice, as in array 5 to 8 equal to 12, the value is propagated or broadcasted henceforth to the entire selection. An important further distinction from Python's built-in list is that array slices are views of the original array. This means that the data is not copied, and any modification to the view will be reflected in the source array. So okay, so if I do a slice, if I say let the slice, and then I say, so if I try to print it, then I say print my ARR. So if it was tuples, then we were going to, oh see, 12 has come here. So 2 2 3 is 0 1 2, right? And then 3 is this thing. So 12 has come in between. Uh, so this is, we are modifying the original array itself. So slice modifies the original array. Now when I change the value, in the mutations are reflected in the original array, right? Okay, if you are new to NumPy, you might be surprised by this, especially if you have used another array programming languages that copy data more as eagerly, right? As NumPy has been designed to be able to work with large arrays, you could imagine performance and memory problems if NumPy insisted on always copying. If you want to copy a slice, you will need, okay, so this is basically, you will be dealing with large arrays, right? So hence it does not create a copy. That is like memory efficient. It modifies the original. If I want to create a copy or not work on the original, then I need to do np dot, so if I do np dot, and then there is method called as, or you mention the array, and then so if I say this is 2 to 3, and then you do dot, so now you can do copy, right? So when I do this copy, there's no need to mention the braces because it's not passing anything, right? And now let's assign it to say array 3. Remember, this is array 3 is a copy, right? So if I do array 3, this shouldn't work, or let's print this thing. So this is a copy. This is not the original array. I have a copy present in it. So built-in method of NumPy object. So I have a copy that is being generated over here. With higher dimensional arrays, we have more options. In a two-dimensional array, the elements already in this are no longer scalars but are 1D. So if I have a 2D, so to have a 2D array, the way you do is array 4 is np dot, again we are using tuple, right? And then inside the parenthesis, this is first one, you have one more parenthesis, one more square brackets, right? So every element is having a, so this is, oh, there is a, the parenthesis, there is one extra bracket which has come here. Yeah, so this is one, one. So this is 1 and this is 2. So this is a 2D array. The individual elements can be accessed recursively, but that is a bit too much. We can use comma separated of list, right? Now how is this represented inside the memory, right? Like how to virtualize it. So for example, so this is a 2D. So consider this as a 2D box. Right. Yeah, so this is a 2D, right? So you have one axis that goes over here and one axis that goes over here, right? So this is axis 0 and this is axis 1. So it will be, the elements will be placed like 0 comma 0, 0 comma 1, 0 comma 2, then you have 1 comma 1, and so on. This is sorry, 1 comma 0, and then you have 2 comma 0, 2 comma 1, and then 2 comma 2, right? So you have two axes that are going to work. 3D is going to be more complicated, right? You have three axes now. So if I have a 3D here, now you can just slice it, right? So the slicing, okay. Now in multi-dimensional arrays, if you omit the later indices, the returned object will be a lower dimensional array. Okay, so this is a 2D array, right? Now how to slice a 2D array? The expression is the same though we had indexed in two steps. Mm, now he's indicating like, so the moment we slice it, right? So now we have two things to be mentioned here. One is along which axis 0 and axis 1, I guess. So if I say this is 2 and this is 1, right? So this is let me check how this is happening. 2D array slicing. How is this going to work? Yeah, that is row start row and column start column. I get that. Uh, so this is row. This is column. So from starting row till row 2. So this is row number 0, row number 1, row number 2. And this is column is 0 and 1, right? So all the end column is 1, right? Shouldn't it that happening that way? Okay. And if I want to get, also we are not including the sliced. Whenever you have this is not included. So this thing is not included. So this is 0 and this is 1, right? And that also, in that I need 0 till, so this chunk is not going to come, I guess. If I do the slicing over here of this, if I say I say equivalent to that, chunking is how it's going to happen. Take row 0 and 1, not including 2, which I got. Take only column 0. Yeah, so this is slashing the column as well, right? If I take another color, this is also going to get slashed. So the only element that I have is 0 1. Yeah. So this 2 is what I'm going to get over here. Okay. So this is how it's going to work in NumPy, right? Now if I have say 2 and this is including all, right? So I have, so this is row 1, so this is all, it's going to take all the elements here. So it's a 3 comma 2, yeah, that is 2 comma 2. How? Yeah, one row, no, but it's going to be 2 comma, how? Oh, so the one is okay. What he's mentioning is one, okay, so then this is going to be from 1 till end, right? So this is 1 till end is this chunk which is going to go, this is 2 comma 2, right? If he's saying 1 colon 2, right? So 1 is again, if I come back here, this is row 0. Okay, row 0 is perfect. I'm going to select row 0, and then this is still 2, right? So this is not going to be excluded, so it will going to be 0 and 1. So first row was 0th row, only 0th row, and then that too, yeah, is it only these two elements that are going to come here? I guess it's going to be only 2 columns. So this is how arrays are, right? Now Boolean indexing. Now let's consider example. We have some data in an array and an array of names. I'm going to use here. So random is basically just going to generate a random number generation, right? So you can have a Boolean array as well. Okay, so one more thing is we can do. So you can do comparisons. Array can be compared, right? Now these are all. So in these all arrays, I guess broadcasting would hold true. So there is a list of operations in which broadcasting should work, I guess. So if I'm performing any of these operations, for example, uh, first is arithmetic, right? Yeah, subtraction, multiplication, division is power. Then you have modulus and you have float division. So here broadcasting is going to work. Second list is equal to, not equal to. Oh, so all operations. So majority of all operations are um, so majorly all are also majorly all are broadcast. Okay, even logical operations like and or okay. When does broadcasting does not work? Whenever we are doing matrix multiplication, right? For example, np dot, that is when it won't work. So the np dot thing that we saw, yeah, matrix multiplication. Now this is something where it won't work. We saw slicing, right? You can be indexed boolean as well. Now boolean selection will not fail if the boolean array is not correct in length. Uh, you can use and or, that's okay. Now you can do something called as fancy indexing. Or this is something that we would be doing. Okay, we'll see that. Now boolean. Let's consider an example where you have some data in an array and an array of names with duplicates. That that distribution we'll see later on. Oh, so what we can do is, now since it's has that broadcasting feature, right? You can directly perform a comparison. What he's trying to say is, uh, So if I can compare this thing, so he's saying I can have a where elements are equal to say 5, and then just print when I do print. Okay, just run this cell. This I've got the uh, boolean array, right? Okay, a boolean array can be passed while indexing the array. This is so if I say I have which is array 3, so array 3 is this one, right? So array 4 is this one. There is 4, but then why it's giving, oh, this is 3.4. If I change this and add on a comma here, no, it shouldn't be giving something. So yeah, you got the true, right? Yeah. I suppose each name corresponds in a data array. Okay. Boolean selection will fail if the Boolean array is not currently length. So I recommend it care. The Boolean array can be passed when indexing the array. So instead of indexing it with like 0, 1, 2, 3, what is it trying to do here? There's something he's trying to do it. Let's the Boolean selection will not fail with the Boolean. Oh, so there is something called as masking. Now what is it doing is, now there is a new so a mask is a Boolean array that is used to filter or select specific elements from another array. uh, oh, I can, so what is this, I can pass this mask inside. So wherever it's true, it's, oh, now I got this mask, right? So you can say this is, you can assign this to say mask. So and then, so this is going to be that array, right? And then what I can do is, instead of just pass this mask inside, are you saying even this will work? So yeah, the region where it's true, right? 4, only that is going to come. Now even if there's a mismatch array, mm, if there is a mismatch, so if for example, okay, let's do with array, yeah, let's mask it on array 2 instead of array 4, and then let's run this. The index error, too many indices. Oh, now if broadcasting is not possible, then it will not, it will give you this array. There is a rule for broadcast, right? We just saw one of the arrays for broadcasting to happen, if the dimensions are equal, or when one has a dimension of when one of the elements should have a dimension of 1, right? So uh, when this has a dimension of 1, why is this failing? So why does broadcast not work in here? No, what is no? There is it's giving an invalid mask error. What's invalid? I'm trying to understand why did broadcast not happen there. And some okay, you cannot do broadcast for indexing. So NumPy expects this mask to match the array shape exactly if you are trying to do a mask. So it's better to check the shape. So there are certain operations only for which the broadcast works, right? I didn't mention. For example, arithmetic, logical, comparison. For masking, it does not perform that. So if it's not performing, so we are not no we are not performing the operation, right? We are trying to mask it. So NumPy does not broadcast Boolean masking. So say since it's better to check the shape before we are doing any operation. So I guess yeah, that is all for this session. I hope you guys liked it, and continue with another one. We'll continue to complete NumPy and then we'll go on from there. So yeah, that is all for this session. Hope you guys liked it. See you guys in the next one. Till that time, take care. Bye bye.